a line. Then the 2, let's say the 2 is here. So since we're not given any value for the y-axis, automatically that means that there will be a broken line such that it coincides and passes through the points where x is equal to 2. Then this part will be shaded. That is to show that that is the region where we are talking about. So the region of x greater than or equals to 2 will be this region. So it will be outside the region that is shaded. So this will be the nature of our graph. Then in the other case where our y is greater than -3, here it will fall to the downward region. So we still draw or we sketch our Cartesian plane where we have our x to be here and our y to be here. Then, since our y is greater than or equal to, when our y is equal to -3, that will be the equation of the line at that point. Then our y is greater than -3. Let's say our y is -3 here. -3 is here, and this is the point of origin. Automatically there will be a broken line here that will coincide with that minus. This is the -3, and it will pass through it towards the negative, towards the positive region of x. So here, then we shade this. So this region that is shaded is the region of our graph, that is y is greater than -3, and you have your y to be greater than -3 here. So that will be the region outside this y equals to -3. So that's these two examples are examples to justify the Cartesian plane. And a case whereby we're asked to draw a graph of x greater than 1, x greater than or equals to 2, and y is greater than -3 on the same Cartesian plane. Then in that situation, we have our vertical axis and we have our horizontal axis. Our vertical axis, which is our y, then our horizontal axis, which is our x. So here, x is greater than, then let's say the point, this is the origin, and this is 2. Then this is the origin, and let's say this is the -3. So here, then we have for the x greater than or equals to 2, we have x equal to 2 as the equation of the line. So the broken line will coincide at that point and passes through it to the negative y. So, and for the y greater than or equal y greater than -3, then we have another broken line passing through this point this way. Then that means the region that we shaded now will be this region. This is the region that we shaded, and this also will be shaded. This region will be shaded. Then your y is greater than -3 will be here, while your x is greater than or equals to 2 will be here. So this is a graph of x is greater than or equals to 2 and y is greater than -3. Exercise. There are 3 questions designed for this topic. Question number 1. Show on a graph the region that contains the set of points for which 2x plus y is equal to 3 or is less than 3. Then 2. Show on a graph the region that contains the solutions of the simultaneous equation 2x plus 3y is less than 6. Y minus 2x is less than 2. and y is greater than or equals to 0. Question 3. Solve graphically the simultaneous inequalities. 4x plus 3y less than 12. Y is greater than or equals to 0 and x is greater than 0 for the integral values of x and y. So to attend to these questions, the question number 1, if you look at the question number 1 closely, you discover that a particular inequality is given to us, and that is 2x plus y is less than 3. That's the inequality given to us. And we are asked to show on a graph the region that contains the set of points for which this particular equation. So the first thing we do here is to make y the subject of the formula. We make our y the subject of the formula, and by so doing, the first thing we do is to transfer this one to the other side, and when it crosses this inequality sign, the sign changes. You have y less than 3 minus 2x. The boundary line will definitely be that point where y is equal to 3 minus 2x. That will be the boundary line. Then a point above it is the region that does not satisfy this inequality. So the first thing we have to do now is to, since we know our inequality will be y equal to 3 minus 2x, which is the boundary line, when x is equal to 0, what will be the value of our y? So we can determine that here. Then if x is 0, y will definitely be 3 minus 0, and your y will be equal to 0. So the coordinates for that particular point will definitely be 0, 3. That's x is 0, y is 3. Then when y is equal to 0, our x will definitely now be 0 equals to 3 minus 2x. Then it should now be 2x equal to 3, which implies that our x will definitely be 3 over 2, which is equal to 1 over 1 over 2. That means you have at y0, y equal to 0, x is 1 over 1 over 2. So these are the two critical points that must be considered in sketching the inequality graph. Now, the next thing we have to do now is to sketch our graph. And if we want to sketch our graph, this is our y-axis and this is our x-axis. This is our x-axis and this is our y-axis. Remember that this is the point of origin, which is 0. Then we have, let's say this is our point 1, this is our 2, and let's say this is our 3. Then let's say this is our minus 1. Then on the x-axis we have 1, let's say 1, let's say we have 2, and let's say we have 3. Where this one will be minus 1, minus 2. For example. Now, at the first point, when x is 0, y is 3. So it will be this point. It will be this point. That's where x will be 0, y will be 3. Then, when x is 1.5, y is 0. When x is 1.5, y is 0. Let's say this point. Automatically, this at the point. So this is where the broken line will come. So it will originate from this point, and it will cross the first point and moves towards the second one. Let's say I move towards the second one. Let's say it's there. So I need to move to pass this point downwards. Pass this point downwards. Though it's not that straight here, just because I am not using a ruler. So I'm just trying to tell you that, or to show you that this is the boundary line. That is where our equation is y equal to 3 minus 2x. So this point is 1.5, 0. Why this one is 0.3. That's the point. Then, since we have succeeded in locating these 2 points, automatically these are our boundary line. Then that means that y is less than 3 minus 2x will be this region where we can shade.